Okay, now that we have made this scatter plot, we're going to learn very specific ways on how to analyze the scatter plot. Anyone can plot the points and make it look pretty, but your job as an intelligent analytical thinker in 8th grade is to describe what the data is trying to show you. What does this mean about the relationship between population in a city and number of airports, or calories in a can of pop and grams of sugar in the can of pop? Your job is to describe it in very specific statistical ways how these two variables are related. In order to help you do this, we're going to learn 4 ways today. The first one is clustering. When you think of a cluster, you should think of a group. Things that are packed closely together. Looking back at our data set that we just made a scatter plot for, you can see that there are a couple groups of data points that are definitely clustered together. These 3 all have one airport, and they're between 1 and 1.25 million and 1.5 million people. That would be clustered together. Clustering helps us show what the normal would be. It's what the group larger amount is. You can do small little clusters that are packed this tightly, or something like this, that would take 6 of the data points and say that most cities in America that are in the top 10 population have 1 or 2 airports. The others would be what we're going to talk about for number 2, which is an outlier. An outlier is not normal. Okay. It is a data point that is way different than all the others. Looking at this data set, the most obvious outlier would be New York. It has 4 million more people than any of the other cities. It has 6 airports. LA comes close with 5, but LA has a significantly smaller population than New York. New York would be a giant outlier. Also, an outlier here might be the city right here. With only 1 million people, they have 3 airports. Another example, listed up top, would be Washington, D.C. You didn't graph D.C., but D.C. has a population of roughly 600,000 people, and they have 3 airports, major airports. The point would be right over here. Okay. That is different than where the majority of the data would be, which is roughly 1 and 2 airports. We call those outliers because they're different. They lie away from the normal data. Number 3 is how the data is associated. Okay? What its association is. There are 2 different ways that data could be associated. Either positive or negative. If your data has a positive association, more X equals more Y, or more people equal more airports. I think it would be safe to say that usually more people in a city equal more airports. Not always the case. There are certain outliers like DC. But for the majority of our cities, the more people there are in that city and metro area, the more airports you would have. It makes common sense. Negative association is more of your X variable equals less of your Y variable. So if more people led to less airports, that would be a negative association. It wouldn't really make much sense in this example, but it will certainly in other examples. And last but not least, our 4th descriptive characteristic is whether or not the data has a linear association. Your data, if it has a positive or negative association, will either be linear or non-linear. Fix that little E right there. Okay. Linear doesn't have to be a perfect straight line. It just means that the data goes up roughly in one direction or down in one direction. So I would say that this data set is linear. I can draw a rough line that approximates my data. We'll get into that example more later this unit. Nonlinear data would look something much more like what I'll draw in red. Goes up and then down and up again and down. Something like this is very clearly non-linear. If your data points would be somewhere along this line, and they go up and then they go down and they go up again and down, that is very clearly non-linear. Or if your data set looked like this, a little parabola, it would not be linear. Pretty common sense. Number 3 and number 4 should be pretty common sense for you. Just think about it, whether or not it's a positive association or negative association, just like it would be a positive slope on that line or a negative slope on that line. We are going to use these 4 descriptive characteristics to analyze our scatter plots, to decide if our scatter plots have clustered data close together, if they have lots of outliers, and especially the association between the variables. And if it's linear, we're going to learn how statisticians do their best job of approximating the relationship.